dy over dx. So the first thing that I would do is I would write dy over dx, and I'm going to go ahead and take Luca's advice, and I'm going to go ahead and write it in a different color over here. So I'm going to put my 2y plus cosine of y in the front. So we're going to cross multiply here. Now he said, let's do this one first. Let's multiply that over. Now, have I separated my variables completely now? Abby, do I have all my variables separated? Are all the x's on one side and are all the y's on it? Okay, so what's the only thing left for me to do? Yep. And again, we're just going to use multiplication to do that. So then in our next step, we're going to have the following. We're going to have 2y plus the cosine of y dy. This is in parentheses. And then, like she said, we're just going to multiply that dx over to the other side. So I'll go ahead and do that in a different color as well. Let's just stick with purple. This is the most important step. And you might look at this and you might think, Mr. Brown, that's so easy. Anybody can do it. You're right. But it is very important that you do that. Again, I'll mention that here in just a second. So now I have everything, and I wrote something incorrectly here. This should be a y. So this is a y. That's still a y. The dx is on the right-hand side. Now I have everything in terms of y on the left and everything in terms of x on the right. So now at this point, the variables are separated. Now we can integrate. Go ahead and now integrate. So now we're going to use all the stuff that we've been practicing in chapter 4. And let's go ahead and do it in green. We're going to do the integral of 2y plus cosine of y dy equals the integral of 6x squared dx. And this is not a difficult integral. I only have one slide here, so I'm going to have to squeeze this in over here. Okay, so what is the integral of 2y? Well, I think that'd be y squared. What is the integral of cosine y? Well, I think that would be sine y. Equals. Now I've got to integrate 6x squared. So x is going to go to the third. I have to divide by 3, so that'd be 2x to the third. And then don't forget the plus c. The plus c is that constant of integration.
So does the dy and the dx go away?
They do. The only thing the dy and the dx are doing is they're telling us that this particular integral is with respect to the y variable. And that's why it's important that we separate them. If this, remember a minute ago when I left that y as an x? We can actually integrate that, but it's multivariable calculus. We're not doing multivariable calculus. And I'm just letting you guys know right now, any equation that's written like this, you will be able to separate the variables. So all the x's are on one side and all the y's on the other. In fact, if that's not the case, you can just say, we don't know how to do that. If you take multivariable calculus when you go to college, you guys can deal with those situations, but let's not worry about that today. Now, this particular equation, I have a question for you. Can I solve it for y? Can I solve that equation for y? Can I get y by itself? Well, the answer is no. And the reason the answer is no is because here you have this y squared. So you'd almost think that maybe you could move that over there, but look what's in that sine function. It's also a variable y. You cannot get the y by itself. So what I'm trying to tell you is this is probably the absolute best way to write your answer. In fact, let me write that one more time just so that it looks a little bit clearer.
And why isn't there a c on the other side?
We talked about that last week, but we can do it again right now. Sine of y plus, and I'll call it c1. Equals, and then 2x to the third plus, let's call that c2. So let's say we do the constant integration on both sides. So remember, a constant is just a number, right? So if I subtract that number over to this number, guess what I still get? I just get a number. So that's a good question, and it's probably worth me repeating it anyway. So I'm going to rewrite this now a third time, plus c. Guys, a constant plus a constant will always be a constant. A constant times a constant will always be a constant. So generally, you'll only see me put one constant in these intervals. Okay? Comments or questions on that first example? Good question. All right, so this is what we call a indefinite integral. And the reason it is an indefinite integral is because of the c. Oh, and I just remembered, I have a poll question, guys, for you that are virtual. If you would please answer my poll question, I'd really appreciate it. Remember, I'm not grading you for that, but I would appreciate it. I'm taking the time to do this, that you would at least give me a shot here and try to answer the question. Okay, so let's look at example 2. Now, example number 1, I did an indefinite integral. Example number 2, I'm going to give you an initial condition. So this is going to be a definite integral. So this is going back to section 4.1 was indefinite integrals, and then section 4.4 when we looked at fundamental theorem and calculus, that was definite integrals. All right, so what will we do to separate those variables? Riley, what do you think? We got dy over dx equals x squared over y squared. How are we going to separate those variables? Just cross multiply. That's all we're going to do here. In fact, I'm just going to do that all in one fell swoop here. There you go. Are the variables separated? The answer is yes. All the y's are on the left. All the x's are on the right. We can now integrate. So let's go ahead and do that. We're going to integrate y squared dy equals x squared dx. Well, we already looked at a squared one, so that should be y to the 3 over 3, I think. So that'd be y to the 3 over 3. And of course, x squared is going to be exactly the same thing, except with the variable x. And then don't forget your plus c. Now, pay particular attention to this one, because just a few minutes ago, Lucy asked me a question about the c's on both sides. Do you guys see the 3 in the denominator of that first term and then that second term? Could I multiply this entire equation through by 3 if I wanted to? It wouldn't change anything, would it? So let me just go ahead and show my work here. So if I wanted to, I could multiply this side by 3, and I could also multiply this side by 3. Now, stay with me here. Can you appreciate why this is going to be y cubed equals x cubed plus c, and not 3c? Because remember, what's 3 times a constant? It's just a constant. Furthermore, I'm going to make one more adjustment here. I'm going to say this is okay, but in this particular example, if I wanted to, I could do the third root of that, right? I could get get y literally by itself by doing the cubic root. Does that make sense? This is what we call our general solution. I'm going to leave that there for a second. Let's see how our poll question, okay, good. Poll question looks good. Looks like most of you voted. A couple of you, yeah, that's good. The answer there was 15,091. Okay, so our general solution is here. So this is the answer for part A. Now, part B, they want us to find the particular solution. The particular solution is given that y of 0 equals 2. In other words, we're going to plug 0, 2 in for this to find the value of c. And that should be pretty easy. So let's go ahead and do that. I'll do the purple. So y is 2, so I put 2 in for y. Cubic root, and then I'm going to put 0 in for x plus c. Well, what's 0 cubed? It's just 0. Plus c. Well, that's just c. So I get 2 equals the cubic root of c. Now what do I do? Well, how do you undo cubic roots? You cube them. So I'll just do this in red. So this is going to be 8 is equal to c, which is going to give us our final answer. I'll do that in blue. Y equals the third root of x cubed plus 8. So how is this problem different than the first one we did? Well, this one, we didn't just find the general solution. We went ahead and found the particular solution. Remember, the general solution right here, this is infinitely many curves. However, in this problem, they want us to say of all those infinitely many curves, which one passes through the point 0, 2? That would be this one right here. This one would be the particular solution. So please make sure you can differentiate the two of them. Remember, the general solution is going to have the C value. In the particular solution, you're actually going to determine what the C value is. Okay, I think I mentioned this earlier. I think this is hopefully the presentation back. Yeah, here we go. I guess I didn't need that extra slide. I needed the extra slide on my first example. This is the rubric for a differential equation problem on the AP exam. And just to remind you guys, the AP exam is, I believe it's May 4th. May 4th, I believe. And here's what I want you to know. This is for one particular component of the AP exam on a free response. It's out of 5 points. So by the way, all the multiple choices are 1 point. This one piece of the free response, which is a total of 9, this one question, which is the separation of variable, it's out of 5 points. And here's what I want you to notice. In fact, I want to highlight this, and you may want to do this in your notes too, right here. And I'm going to read it to you very slowly so that it hopefully sinks in. Note, 0 of 5 points if no separation of variables. Which means you could be doing wonderful math, you could be doing awesome calculus and getting all your integrals right. And if you do not separate, if you forget to separate the variables, you're going to get 0 points. And I'm not saying that with joy. I'm just telling you, I mean, how hard is it to separate the variables? It's not really that hard. Usually it's just a matter of cross multiplying. It's super crucial though. If I'm, and by the way, this year I hope to be reading for the first time. If I'm looking at this particular problem, if they don't do this first step, I don't even continue looking at the problem because it's now 0. So it's very important. In fact, let me just go back here to this last example I did. This step is probably the most important step, even though it was probably the easiest step. So make sure you show that when you're practicing these things. And I'll remind you as we get closer to the exam. Okay, so we're doing great on time. Okay, so this one here, I'm going to let you try. Okay, I'm going to give you a few minutes. Maybe you can get it, maybe you can't. I want you to try on your own. This one's going to be a little student practice. I'm going to do the problem too, so don't get too nervous. I just want you to try to separate the variables and start trying to get this going. I'm not going to give you a ton of time because I don't want it to be wasteful, but I'm going to give you a little bit of time. We're going to practice this as a class here in a few minutes, but I'm just going to give you a few minutes. I'd like you to try to tackle as much of this one as you can on your own. And by the way, while you guys are working on that, I'm going to give the virtual students another poll question here. Good. Okay, we're about halfway there. 90 more seconds. Okay, it looks like not quite as many of you have answered that poll question. I'd appreciate if you would answer the poll question, please. Again, I'm not grading you for it, so if you get it wrong, that's okay. Okay, so first questions first. Is this one, are we trying to find the general solution or are we trying to find a particular solution? We're trying to find general, right? Because we don't know what the initial condition is, so we know it's going to be general. The first thing we want to try to do is separate the variables. So the first thing that I would recommend that you do on problems like this is change that y prime to what, Luca? You got it. We're going to change that dy to dy over dx. So I'm going to say x, y, dy, dx. That way I'm not tempted to think that this is just a y variable term. Does that make sense? You want to change it to dy dx so that you can make sure you get everything separated. So I think it's probably clear that you could divide by x, right? So you get y dy x squared plus 1 over x. And then the other thing is I'm just going to go ahead and multiply by the dx to the other side. So this, now I've got my variables separated. It wasn't a very difficult one, but maybe you could appreciate how it might be, a student might screw that up. They might accidentally just leave that y prime right there and just make this y prime. Technically, that would get you 0 points on the AP exam. You got to be careful about that. We want that dx. Now we can go ahead and integrate. So I'll just go ahead and add my integral symbol right here. The left-hand side is very easy. So this is going to give me y squared over 2, and I'm not going to put the c yet. How am I going to handle the right-hand side? That's what I'm really interested in. That's why I actually put this problem on. Any ideas? How am I going to integrate? And this can be someone in the virtual class as well. How do you integrate this x squared plus 1 over x? Yeah, Riley, go ahead. Sorry.
If you separate them like x squared over x and 1 over x.
That's exactly right, Riley. Good job. That is exactly right. So what we want to do here is this x squared over x, and then just do 1 over x. So what we're doing here, if you will, is we're kind of distributing the 1 over x. And of course, x squared over x is just x, and 1 over x, well, there's not much I can do with that. It's just 1 over x. However, now I'm going to be able to integrate this. So this is going to become the integral of x plus 1 over x dx. So my left-hand side's already done, but I had to do one little algebraic step. So I just want to remind you, sometimes you have to massage these expressions a little bit. Now we can integrate the right-hand side. So we're going to get y squared over 2 equals x squared over 2 plus, does anyone happen to remember what is the integral of 1 over x? It is the ln. Very good. It is the natural log absolute value of x plus c. Don't forget you need the absolute value there. Can anyone guess what I'm going to multiply both sides by? You got it. I'm gonna multiply both sides by 2. I'm not even gonna show my work on that one, if that's okay with you guys. I'm just gonna kind of come right here, and I'm gonna write y squared equals x squared plus. Now, if I'm multiplying both sides by 2, what do I have to put on that ln of x? 2. So I'm gonna put 2 ln of absolute value of x. And then what's 2 times c? That's still just c. Now, I'm almost done. I haven't mentioned this word in a while, but explicit means they just want you to get y by itself. So how do I do that? It's going to be the plus or minus, and we do have to do the plus or minus the square root of the stuff on the right. So plus or minus the square root of x squared plus the natural log of x squared plus c. That's your final answer. Now, in case you're looking at my answer thinking, wow, Mr. Allen, that's really nice, except you screwed up the ln of x part. Did I? Just as a quick reminder from pre-calc, if you have like the ln of x plus the ln of 2, that's the ln of 2x. Agreed? What if I had the ln of x and then I multiplied it by 2? What's that equal to? That's the ln of x squared. Do you remember that rule? You might say, Mr. Allen, what if I left it like I had it written right there? Would that be wrong? The answer is it is not wrong. But I want you to be aware that most of the questions you do on the AP exam will be multiple choice. And they probably will not write this one like this. They'll probably write it like this. And by the way, since this is x squared, I don't need to worry about the absolute value symbol, so it actually makes it a little bit cleaner. Okay, good. So that was kind of a harder one in terms of there's a couple little minutia steps there that you have to be careful of. I've got one more example, and then we're going to do some practice together as a class. Does anyone have any questions on example 3? By the way, thank you guys for answering my second poll question. It looks like most of you got the right answer there. The answer was 8. Okay, let's get this last one. All right, last problem is probably the most important one. This is an application problem. I don't know if you guys like baby cows, calves. We got a calf in this one. It says a calf weighs 60 pounds at birth, gains weight at a rate of, and they give you this differential equation. dW, and W stands for weight, T stands for time. The derivative of the weight with respect to time is directly proportional to K quantity 1200 minus W, where the weight is in pound and T is in years. Solve the differential equation, and then B, the animal is sold when it reaches a weight of 800 pounds. Find the time of sale if K is equal to 0.524. All right, so last week we looked at some practice problems on our second, and that's what we're going to do tomorrow. Guess what we're going to do tomorrow, guys? Today we're watching Mr. Allen do stuff, and then tomorrow you guys are going to be working in groups, and you're going to be practicing all the stuff that we're doing today. So our equation, our differential equation here was dW over dt equals K times, I think it was 1200, is that right? 1200 minus W? Okay, good. How many variables are there in this problem, in this differential equation? There's 2. What's this? It's a constant. Remember, K is that constant of proportionality, so it's not technically a variable. So the very first thing I want to do is I want to separate my variables. In other words, I'm going to let the stuff that has W stay on the left, and I'm going to let the stuff that has T is a variable, and W is the variable in this particular problem. K is not a variable, it is a constant of proportionality. This hopefully feels a little bit like deja vu, because I gave you some problems like this on the activity we did last Tuesday. Now we can integrate. In fact, let me just put my integral symbol there between the K and the dt. Now the right-hand side, that integral is very easy, right? What is the integral of just dt? Well, it's just going to be t. So this is going to be kt plus c. This sounds familiar. Done this way too many times, that's okay though. Now I have to be careful on the left. I would have to do a U substitution where U is this 1200 minus W. So this is actually going to give us the negative of the natural logarithm of 1200 minus W. This may feel a little reminiscent of that Newton's cooling law that I mentioned on that example last week. Now we're going to get rid of the negative, so this is going to be the natural logarithm of 1200 minus W equals negative KT. Notice I'm not changing the C to minus because C is just a constant. You might be saying, Mr. Allen, I'm getting really confused. You have multiple constants here. This is a constant of integration, and this is the constant of proportionality. Yes?
Just like kind of a bunch of things.
No.
So is U substitution just a different way to integrate, like a way to integrate on paper?
Yeah. So here's why we're doing U sub. If I just said, what's this integral? You would say it's the natural log absolute value of x plus c, right?
Yeah.
That's really close to what we have here.
Yeah.
But technically, that's not just w on the bottom. It's 1200 minus w. So in this example, what we would do is we would say u is 1200 minus w. Then du would be negative dw, or negative du is equal to dw. So what I guess I'm trying to tell you is it's not just something we're choosing to do. You actually have to do it. It's just hopefully now at this point, it's kind of becoming more of an automatic process that you can kind of just quickly go from here to here. Does that make sense?
Yeah.
Okay. So in other words, this integral would have literally changed to the following integral.
Okay.
Does that make sense?
To make it simplified.
It does. So now, when you look at this part, it looks exactly like that part, and we know how to do that.
Yeah.
Technically, this isn't quite the natural log of u, or w, it's negative negative. Does that make sense?
Yeah.
Okay. All right. I'm not sure if I gave I didn't. I'm gonna have to erase what I did over here. We're not gonna have enough room. Okay, so we've got our integral done. We're cleaning things up here a little bit. Go. Okay, so how do we get rid of the natural log? We're going to e both sides, just like we did last week. So that's going to give us the following. Absolute value of 1200 minus w equals c e to the negative kt. That's where that c comes from that we keep seeing in these exponential problems. And I left off an absolute value symbol there, sorry about that. Now, I've got absolute value. If I get rid of the absolute value, that means that c has to change to plus or minus c, but guess what? C is just a constant, so it doesn't change anything. So we get 1200 minus w equals c e to the negative kt. Last but not least, we got to bring that 1200 over to the right-hand side. So that's going to be negative w equals negative 1200 plus c e to the negative kt. We don't want that negative in front of the w, do we? No, so I'm going to write my final answer for the general solution is going to be 1200 plus c e to the negative kt. Now notice that hopefully every time I'm doing one of these problems, you're noticing that I'm not changing c to like 3c or negative c, or because it doesn't, we don't know what it's going to be until we actually are given the initial condition. So what I have here in green is the general solution to this differential equation. This is the general solution. So that was question A, and I'm going to come back to this slide, but question A is solve the differential equation. Now, I'm not quite done. I can actually do better than this because they tell us how much does the calf weigh at birth? 60. So I'm going to take this now to the next step. I know that at birth, I'll call it 060, where this is the weight and this is the time. So we're just going to say the time of birth is 0. So that means that 60 will be equal to 1200 plus c e to the Well, if I take 0 in there for t, it's 0 times negative k, which is just going to give us 0. Can you guys see what c is now, just by looking at it? What's e to the 0? That's 1, so that's just going to give us c. And so c has to be negative 1140. You guys agree with that? Now we have our particular solution. I'm going to write this in red because this is the most important equation that I've written so far. Whoops. Oh, my D just disappeared. This is what we need. This is the particular solution for this particular problem. This is the answer for part A. By the way, this is the kind of question that they could ask on a free response problem. They could say, they could give you, in fact, this is actually very similar to one they did in 2017. They expect you to show this work to get to this result. This was probably the most important step right here where I separated the variable. And then, they give you a point for each one of your integrations and then finding the particular solution. So there's A. So let's come back here. Question B says, and I'm going to let you guys get question B. You're going to need your calculator for sure because you're going to have to do an exponential with a decimal. The animal is sold when its weight reaches 800 pounds at the time of sale. If K is 0.524. So my question is, how long is it going to take? And by the way, this is going to be in years because we did this in years. How many years before we can sell our little calf here? It was originally born at 60 pounds. We're going to sell it when it reaches 800 pounds. Go ahead and use K equals 0.524 and determine how long it will take for the calf to be sold. I'm going to let you solve that, and then I'm going to get my next activity going. Okay, can anyone in the virtual classroom tell me how many years it will take till we can sell our baby calf here, our little cow? Round to the, I'll say round to the nearest tenth of a year. How about that? Okay. 524. Can I get anybody to help me out with this one? Hopefully you can see. We're going to put 800 in for W, 0.524 in for K. You've got to figure out what T is. This isn't calculus now. We're just doing pre-calc now. Just got to find T. Did you get something, Lucy?
I got screwed up on that one.
Okay, that's all right. All right, so let's look at the algebra. No one's giving me the answer here. We got about another minute, and then I got to move on to my next activity. Let's go ahead and look at this real quick. Let me erase what I wrote down here. And get your calculator ready, because I'm going to walk you through how to do this with your calculator. So we're going to put 800 in for W, 1200 minus 1140, e to the 0.524. There's a decimal point right there. T. We're trying to figure out what T is. Okay, you got your calculator ready? Now, guys, if you want to show all your steps on your paper, you can. But let's just kind of walk through this. What would be the first thing you would do with that 1200? you'd minus it. So with your calculator, do 800 minus 1200, hit enter. You'll get negative 400. You might say, well, Mr. Allen, I could have done that in my head. I know. Now what are we going to do? So, yep, you're going to divide. Now I'm going to go ahead and show all my work on here just in case someone's like, okay, Mr. Allen, how are you getting that answer? Now we're just going to divide by negative, make sure it's negative, not minus. Divide by negative 1140. I got 0.35. Did you guys get point? Now do me a favor, don't erase that. Leave that in there. That's going to be 0.3508, etc. equals e to the 0.524t. Now what? This is probably the hardest step for people to remember. Now we're going to natural log it. So you got your answer here. Hit natural log and then just hit second function minus, which is the answer, and hit enter again. And I get negative 1.0473 ... equals, and then you're going to 0.524. We're to the last step now. Now what? Just divide. We need to divide. So we are going to divide by, oh, and I made a mistake. Does anybody see my mistake? What's negative? The K was negative. Do you remember over here I said that this piece right here, this K, it needed to be negative? Very important. Guess what I ended up doing here? I left off my negative right here. There should be a negative right there. So you're going to get T is 1.9987. In other words, it's about 2 years. So after about 2 years of being born, we'll be able to sell our calf. Does that make sense? By the way, you guys can kind of do that with your calf. You do not need to show all these steps right here. If I was grading your test and this problem was on there, I'd be grading the separation of variable. I'd be grading the antiderivative. I'd be grading, okay, they got the general solution. Okay, they got the particular solution. And then I'm going to grade this final piece. I'm not even going to probably grade these steps here. Now, I might give you feedback on them, but this is just algebra, right? Basic algebra. Okay. So let's move to the next first one. Does anyone have any questions on that last one? That one was kind of long and I kind of screwed up my negative there. I'm going to quit recording now that I'm done with the content piece. And now we're going to practice some of this stuff. I've still got you guys for another 8 or 9 minutes.